As a Workbench Wednesdays episode on the Element 14 community, I made a video on replacing aluminum electrolytic capacitors. The device I used as a test case was a TRS Model 100 portable computer from the 1980s. It had 17 capacitors to replace. In that video, I did not show selecting every single one of the capacitors on a distributor website. So in this video, I have the full session where I go through and select every single one of them. I know that this gets repetitive, but it's the process that I went through. For a shorter version, check out the Element 14 Presents video. All right, so I'm going to use Newark as my distributor for hopefully obvious reasons, but I think the things I do here should apply to any distributor because we're basically just going to look at what are the ways that we filter stuff out. So let's go to capacitors, aluminum electrolytic. And then for most of these, they're leaded, so we'll do leaded aluminum electrolytic. Okay, and so the first one we're gonna do is those 4 10 microfarad 16 volt caps. And so I wanna select anything that's in stock for, make sure it's available. And then I'm gonna select 10 microfarads. And then for the voltage, it's 16 volts. And I'm only going to select a few voltages higher, a few voltage points higher, because once we get beyond that, size of the cap is probably going to be bigger than what we want anyway. And then down here I want radial lead it, and you'll see that in this case we only have 6 options available for 4 millimeter. So I'm not even going to filter that. And then down here what I'm going to look for is the diameter, and the diameter is 7 millimeters. Oh, sorry, 4. Duh. I'm looking for height, or what I call length, and so we want anything that is either 5 or 7 millimeter. And then finally, I'm going to go ahead and preemptively select, I want 105C rated parts. All right, so that gets us down to 7 parts. Right, and then at this point, I'm just going to not even bother looking at anything. I'm just going to select these all so that I can compare them in a table. And now we can kind of go through the same filtering that we just did. So first we look at the prices. So this one's got a really good price on it. It's probably a special. 15 cents, 20 cents, 30 cents. So there's got to be some kind of differences going on here. These only have 2 available. So you know what? We're just going to take this right out of the list. So now I'm going to pay closer attention to some of these other things. So you'll notice almost none of these caps that we look at in this exercise will list their ESR. Some will list their ripple current, but in general for these smaller caps, the data is not available. What I'm really interested in now is if I look at the lifetime, we already selected 105C. And if I look at this, we can see one cap is rated for 5,000 hours at 105C, which sounds really good to me. The rest of this stuff is going to be about the same, I bet. So 4 millimeter, I selected a 5 by accident. 35 volt when we only need 16. And let's just go double check the price on this one. It's 17 cents. This is a winner. So I will add, let's see, we need 4 of them for our design. I'm actually going to add 10 to my cart. Delete all, back to previous page, and then I'm just going to start our search over, go to leaded aluminum electrolytics, to aluminum electrolytic capacitors, let's say in stock, and then down here I will select 3.3 microfarads, and then over here, let's see, 3.3, let's go 50 volt and 63 volt. So let's go ahead and filter that down because that'll make for fewer options to select moving forward. I want radial lead it. I didn't mean to click show results. Just habit. Oh, yeah. By the way, so this one comes in PC pin. You probably don't want PC pin. This is a different type of pin or terminal on the capacitor. And so unless the one you pull out has these really short, stubby, stiff pins, you want radial lead it. And obviously if it's axial, then you want axial. I guess I should say that at some point. The one thing I didn't measure, and I should have, was the pitch or lead spacing, but I think we're going to be okay on most of these. I'm more worried about them fitting anyway. If the pitch is a little off, you can usually shove them in there. I shouldn't say that. Okay, so so the diameter is going to be 5 millimeter. We could go for 4, but I have a feeling we're not going to want to. Again, I'm going to select 105C, and then that gets us down to 9. Okay, we'll go there. So same story as before. I'm just going to blindly select them all. Here I see this one only has 2 in stock, so I'm just going to skip it. Compare selected. All right, so now I got a bunch selected. So let's kind of look through. Okay, so prices are all about the same except for this one over here is only 2 cents each. I'm going to guess that's a special deal. So same cap, obviously lead spacing is all the same, temperature ratings are the same. What I'm noticing is there's a couple with -55 versus -40. While it doesn't matter at all for most like applications where it's going to be, where equipment will be indoors, if you are working on something that's going to be outside, you might want to pay attention to that. If nothing else, select the -55 because it usually means the electrolyte is slightly less aggressive, I think. Usually I just select it because I figure why not. Now these parts have an AEC Q200 qualification. That means that they have been qualified for automotive applications. It does not mean they're better quality than the other components, which some people think automotive grade means better quality. It just means that the parts have gone through more qualification testing, which may result in a better part. But the reality is it just means that there is a process that has been validated by the AEC, or Automotive Electronic Component Council, Reliability Council. I forgot what they're called. Anyway, so for our application, this would be if there's 2 caps that are roughly the same price and I can't decide which, then I get AEC Q200. Otherwise, I'm not going to worry about it. So in this one, see, ripple currents aren't really rated, but I'm seeing like this one is rated at 18. These are 65 and 53. So I'm probably going to ignore that one. And then these are all 50 volt except for this one. So what was their lifetimes? 1,000, 2,000, 5,000, 5,000. So let's pay attention to this one and this one, which I think they're both 50 volt rated and neither are Q200. So that's 1, 2, 3, and then 1, 2 from the outside. So 1, 2, 3, 1, 2, 517 and 1,000. So there's 1,000 of these and they're 26 cents. We're just going to go with those. In stock, 4.7. Let's do 25 and 35. And then let's see if there's a diameter selection. Because I think we'll care about that. Yeah, so let's get a 4 millimeter diameter, which is what we had before. And then for the product height, we need something that is less than 7 millimeters. So I'm not going to bother selecting those. And since there's only 2 that are 105C, hold on to this. Instead of filtering on that immediately, I want to see something. So since this is going to be 8 parts, let's go and do all of this. I wasn't paying attention to stock. So most of these, there's 52 of these. For my case, since I'm repairing, I think 50 is enough that I don't really care. So then I want to see, 105, 105. But what I wanted to look at is there's 105 at 1,000 hours, 105 at 1,000 hours. See, and this is why I wanted to be careful, because this one is rated at 2,000 hours for 85C. And so this could be an option. However, when you look at life, if you remove 10 degrees or back 10 degrees off the temperature, that doubles the life in general. So if this is 1,000 hours at 105C, at 95C, it'd be 2,000 hours, and at 85C, it'd be 4,000 hours. So I wanted to compare this because sometimes it may actually make more sense to get an 85C with higher life rating than a 105C with a lower life rating. In this case, it doesn't. So in fact, I'm just going to take this one out of our list because that comparison doesn't hold. So then down here, I've got a 7, a 5, and a 7, and a 5, a 7, 5, 7, 5. For the height, originally ours was 7. So then I'm going to look at rated voltage. So I'm liking the 35 volt parts better. Let's go double. Okay, do we have a ripple current? Not really. So that doesn't really help us. So let's see 35. So the middle 2 are 25 volts. So we've got 28 cents, 33 cents, 24 cents, 32 cents. So here's where I'm going to lean on this one. These outside parts are 35 cents. Or I'm sorry, they're 35 volts. And if I'm looking at this, there's 3,000 of these and 94 and blah, blah, blah of these. So I tell you what I'm going to do on this one. I'm going to go for, well, this is a tough one. I think we're going to go for the multi-comp part just because there's a lot more of them in stock. I don't know. The price difference is not enough for me to make a call. So I'm just going to select the multi-comp. Let's go 10 of these, add to cart. This is kind of cool. We're replacing this one with something that's 105C rated and is rated for higher voltage. So that is going to have a really long life compared to what used to be in there. I'm pretty sure all the ones that were in the design were only 85C caps. So, okay, next up. So this next one is 470 mic at 10 volt and 470 mic at 6.3, and they're both 10 by 12 millimeter, which I'm thinking I might have measured them wrong, but those are so close. We're just going to replace those with the same cap. So let's start this and go in stock. And then I want 470 microfarads. And for the rated voltage, we want something that's at least 10, ideally 16 volts, but we'll see how this comes out. Radial lead it. And for the diameter, we want 10 millimeters or 8, really. I'm going to select that because we may find something in an 8 millimeter package. And then for the, wait, did I select something different up here? Diameter. And then down here is product diameter, whatever. So product height has to be less than 12. I am going to select 12.5 because that's probably close enough. All right. And then what about our temperature rating? I'm going to just... I can actually cheat. We're going to look at this. Yeah, we'll just do the 105Cs. Okay, let's see what we get. Back to previous page. 1, 2, 3, and 4, 5, 6. I thought there's 4. Whatever. All right, let's take a look at these. So first, I wasn't paying attention to stock. So how many do they have? 1,000, 800, 3,000, 300, 700, 200. Okay, so we got plenty of stock available. 470s, so 10, 8, 8, 8, 8, 8, 8, 10. That's nice that they're on the outsides. Lead spacing. See, this is where I wish I knew. You know what? Now that I realize this, we're going to stick to 10 millimeter because the leads will probably be too close on an 8 millimeter. So we want the 5 millimeter spacing. So 5,000 hours versus 6,000, negative 55 versus negative 40. I'd rather have 6,000 hours. Let's see, height 12.5. So we are pushing a little bit on the height, but half a millimeter is usually fine. Nothing on the ripple current, although this is rated at 1.29 amps and this is rated at 400 milliamps. So that's interesting. 10 versus 25. Okay, so I'm saying this far right column is the winner. Let's double check and see what the price difference is. 79 cents versus 65 cents. I mean, even at quantity, that's a tough call. Well, at quantity, that'd be a tough call, I should say. Same capacitance, significantly higher voltage rating, 105C. This is going to be a really good cap for that replacement. The fact that we're fitting it in the same space is, well, it's exciting to me, but I like caps. So, okay. Next up, item number next. In stock. So now you're going to do a 33 microfarad at 10 volts. So let's do 10 and 16. And the diameter is 5 millimeter. And then what are we down to? 17. We need a height or a length less than 8 millimeters. So, wow, that significantly reduces our options, doesn't it? So now we've got 3 that we can choose from. So let's select those. So 3,000 in stock. I'm going to compare these. So what are we looking at? Cap, blah, blah, blah. Lead spacing 2.5 versus 2. That's suspicious. Now I wish I had measured the lead spacing. Temperature rating is the same. 2,000 hours versus 1,000. So I'm going to lean towards, since there's 2 cap. Oh, check this out. This is a PC pin. So we can take that one off the list. Now I'm kind of stuck because I'm not sure which lead spacing to get. Product height. This one's a little bit taller. It can handle a little more ripple current and it's rated for higher voltage. I'm going to go for the 2.5 millimeter. I would rather it be slightly wider. And I'm nervous that the Newark cap is so much shorter. I don't like that. So yeah, I'm going to go that direction. Now we'll do 100 microfarads, 10 volts. Start over in stock. 10 or 16 volts. And then we'll select 100 microfarads. And the size is 6 millimeters. I am going to select the 6.3 because it's probably close enough. That's 24 parts are left. Okay. So now let's do a height of 12 millimeters or less. Well, that's not going to help. Those are all. Okay. Let's go down to 105C. Oh, actually, once again, I was going to look at this. So if we look at this here, the 805, I'm looking for an 805 with really high rating. I don't see one. So we'll do 105C. We're going to come down to 13 parts. Okay, I don't want to do a compare of 13. So you know what? In this case, I'm just going to sort by price. So 20 cents versus 28, 30, 35. Okay, so what do we got? This is a 16 volt, 100 microfarad, 2,000 hours. For a few cents more, we can get 5,000 hours, 16 volt on a... Okay, this is our winning cap. It's close enough. Now I need a in stock 1 farad, 1 microfarad, and 50 volt. So we'll do 50 and 63. So I do the one step higher because when you do the sort, sometimes prices on the caps might actually be cheaper, or there could be a special where the distributor is trying to get rid of a certain value. And so it's counterintuitive because you typically want to think, oh, higher rate it must mean it's going to be more expensive part. But sometimes you might end up with something slightly lower. Like in that case, we got a 16 volt cap, even though I had 10 volts selected originally. So to me, it's worth selecting at least one step higher than what you actually need because you may find something that is suitable and at a good price. Don't assume that everything is priced logically based on the specs. Volume plays a big role, and the volume for different manufacturers play a big role depending on who the distributor is. So keep that in mind, is it's not just about the specs. So I'm doing one mic, 50 volt, 4.7. So we better select this one. Let's see, 1,000 hours at 105. Okay, so let's select the 105C. That gets us down to 4 parts. Let's just see what we get. 1, 2, 3, 4. Okay, compare. So in here, let's see. These are all in stock. They're all about the same price. So this is going to be an interesting choice. So 1,000 hours, 1,000 hours, 1,000 hours, 3,000 hours. And it's roughly the same price, right? Okay. So this is our winner at the moment. Length is shorter than some of the others. This correct diameter. Okay. All right. Well, I think that's going to be our winner. It's rated for a longer life. And it's not much more expensive than everyone else. That's pretty, 0.47 microfarads and 50 volts. So let's do 50 and 63. Our diameter needs to be 5.5 or smaller. Let's do radial. Okay, we're down to 4 parts, but I do want to go ahead. Okay, so there's only all the diameters are small enough. So then let's go ahead and clear our previous table. Select these. And let's see, 20, 20, 20, 10, or 12. All right, let's look at lead spacing. Okay, they're roughly the same, and this makes me a little nervous, but not too bad. 2,000, 2,000, 2,000. Oh, so 2,000, these are both at 105C. I'm pretty sure this one's already out. This one's non-polar. Interesting. But let's see, this is rated for 100 volts. What do we need? A 50 volt part. This is rated for 63 volts. So I want to make it, the decision is going to be down to these two. This one claims slightly higher ripple current, which I'm not sure what unit that's in. Must be milliamps since it's a 470 nanofarad cap. Okay, so 100 volt versus 63. Thing is, this one's half the price, so I'm going to go with this one. Or actually, I think we got 3 more. Let's do 220 microfarads and 10 volts. I shouldn't have, we still have to do a few more things. So I want radial, and then I want polar, and then for diameter, we're going to select 8 or smaller. I'm not going to go down to 5. There's no way that's going to fit. And then for height, it has to be less than 12, which is all of these. Okay. Ooh, there's a couple rated for 125. You know what? Let's just go straight for that and see what those look like. 40 cents. They're in stock. All right. Let's compare these two. So keep in mind, I'm doing a repair. So even if these were twice the price, it's still not that much more money. And so I'd rather go for the slightly higher rated component anyway. So might as well, right? My only concern with higher temperature rating is that they'll often have a slightly higher ESR than a lower rated component. But since most of these are just decoupling caps anyway, I'm not too worried about a slightly higher ESR. It's not going to be 2 orders of magnitude. And besides, you know what higher ESR does to a bulk decoupling cap? It generates more heat. So if you can handle more heat, doesn't really matter, does it? 16 volt versus 10 volt. Okay, that's good to know. 1,000 hours at 125C versus, I wonder why that happened. So 16 volt and 125C, and it's the same price as this one. I don't think you have to be the bald engineer to know which one to do in this case. Now I want to do the non-polarized capacitors, which are still in the leaded aluminum electrolytics. The only thing we have to make sure we select is the non-polar filter option. So let's see, 1 microfarad, 50 to 63 volts, we might as well. Radial leaded. I'm going to, Bom. We already don't have it available. Here's the thing. I found this capacitor earlier. So I wonder what I did different this time. Let's try this again. Tell you what, let's do in stock and start with bipolar. And maybe now we'll be able to select from some of the options to see which one we want. 1 microfarad, and that brings us down to 5 possible parts. Okay, and radial lead it, 4 parts. Okay, we're down to 4 parts. Let's just compare these. So let me clear my table from before. I'm not sure why this didn't work before, but this is a good lesson. Just do your search over. No, I mean, start with the most critical aspect first, which in this case, we have to have a non-polarized cap. Okay, so 2,000 hours, 85C, all the same. They're all bipolar. This one doesn't have a height, which is bad news because I don't like when that's missing. And then let's see, this is 100 volts versus 16 and 35. That's suspicious. We need something rated for 50 volts. So this looks like our only option. It's the right length. It's just suspicious to me that this has a lot of specs similar to these over here. So let's click on this real quick and look at a data sheet and make sure that this matches what we expect. So let's see, do they have a part number decoder table? So if I want 1 microfarad and 100 volts, it will be a 5 by 11, which is what we want. So that works. Okay, let's do that again. So this time we need 4 of the parts that we're about to look for. So let's do in stock, same thing. I'm going to do bipolar first. And then I'm going to go ahead and let that filter down just because that minimizes some of the choices now. So we need 47 microfarads. So we'll select that. And I need something that's at least 16 volts. So let's do 16 and 35. We're only going to have 4 available. So let's just go for it. And then select these. All right, let's see what we've got here. So there is a complete price difference. Okay, plenty of stock. This one is the most in stock, so that's interesting. So diameter, we need something that is 8 millimeters or less. Okay, so that's why these are two different lead spacings. It's 6.3 versus 8. I think we'll stick with 8. The height is the same. So then it's 35 volts rated. We need it 16. Okay. I think we're just going to go straight for these parts. And then between these two, the Multi-Count Pro is a fraction of the price. Was that a third of the price of the Panasonic? So let's go with the Multi-Count. Because it's, oh, wait. One more thing. I didn't look at the life, did I? Nope, they're all 2,000 hours. Okay. All right, so that's all we have to do. I'll place the order for these parts, and then we can put those into the Model 100 and double check that it still works.